In this video, we're going to continue our conversation about how to name various compounds, specifically a class of compounds known as oxoacids. And as their name suggests, oxoacids are acids that contain oxygen. Okay, so we've already seen some acids like HCl, which we called hydrochloric acid. We saw that kind of a pattern forming with the ic acid at the end of the names. And it turns out the oxoacids are similar in that respect. So, for example, we could have HNO3, which is known as nitric acid. We can have HClO3, which is chloric acid, not to be confused with hydrochloric acid. Okay, hydrochloric acid does not have the oxygens. We can have H2SO4, which is sulfuric acid. We can have H3PO4, which is known as phosphoric acid. And I'm afraid that you really just kind of have to learn the names. It's got a little bit of a system going here, but for the most part, you just need to know these. All right, so we have nitric, chloric, sulfuric, phosphoric. We have H2CO3, which is carbonic acid. Okay, and that's where we're going to end our list of oxoacids that we're interested in. Well, kind of. What we're going to do here is we're going to classify all of these as what I call parent acids. Okay, and the reason why I use this term parent acid is because for these acids there are other versions of them that vary in the number of oxygens. So for example, let's take a look at the chloric acid. So chloric acid we said was HClO3. Okay, but there's also a compound that's similar to this that is going to have one additional oxygen. Okay, so this would be HClO4. And then there's one that has one less oxygen. So that's HClO2. And then there's a version that has just one oxygen, which is HClO. Okay, and we need to be able to name these. By the way, the nitric acid, sulfuric acid, phosphoric acid, and carbonic acid also have other versions of themselves with different numbers of oxygens. Okay, so this begs the question, how do we name these things? Well, it turns out that we can look at the names in terms of suffixes. So this name ends in ic acid. So this is kind of suffix, it's the end of the word here. We can also use prefixes as well. So just to kind of give you an idea of how this works, I'm just going to give you all the names here and hope that you can pick up a pattern. Okay, so we have chloric acid, but when we have one less oxygen, we call this chlorous acid. Okay, so you can see here we changed the suffix from ic acid to us acid. Okay, and then for the bottom one here we have what's called Hyposulfurous Acid. So here we're throwing in this prefix hypo in addition to the suffix us acid. Okay, and the HClO4 uses the prefix per. Oops. And the suffix ic acid. Okay, so these are the names for these 4 different compounds. Now what we're going to find is that the same naming system can be applied to all of the other oxoacids. But it should be pointed out that not every one of the acids is going to have a version that has one more oxygen or one less. So basically, you're going to find out you don't have every possible name that could be given to these different compounds. An example of this would be sulfuric acid. Okay, notice that chloric acid was our parent acid. Okay, whereas the perchloric acid was the parent plus 1 oxygen. The chlorous acid was the parent minus 1 oxygen. And the hypochlorous acid was the parent minus 2 oxygens. So if we're going to be naming these derivatives of the oxoacids, we kind of have to line them up the same way. So again, if we're looking at sulfuric acid, which is H2SO4, okay, that's going to be, again, sulfuric acid. And just like we saw with the chloric acid, we have that suffix of ic acid. Okay, but there's a version of this compound that has 1 less oxygen. Okay, so this becomes H2SO3. Okay, so here we have 1 fewer oxygen, just like we have in the case here. So we use the same suffix for having 1 fewer oxygen. So this becomes sulfurous acid. Okay, and if we had even 1 fewer than that, that would be H2SO2, and that would be hypo, so that's going to have a prefix of hypo. Okay, the root of the parent name, sulfur, and the suffix us acid. Okay, so hyposulfurous acid. Okay, now if we look at H2SO5, which is the version that would have 1 additional oxygen, it turns out this doesn't exist. Oops. Okay, and there's no way that you could possibly know that at this stage of the game. So don't worry about that too much. I'll never ask you to name something that doesn't exist. Okay, but we're not going to worry about every possible combination here. So for example, in principle, we could have 1 oxygen less than H2SO2, but that's beyond the scope of the course here. So we're just going to worry about these 4 possible scenarios. But again, I want you to notice that the suffixes that we use are not indicative of the absolute number of oxygens. So in other words, it's not like us acid indicates that there's 2 oxygens. Instead, it indicates that there's 1 less oxygen than the parent. Okay, and that's a very important point here. Okay, now, in addition to the oxoacids, we can look at the anions of the oxoacids. So basically, these are the compounds that are produced when you take an H away from an oxoacid. So, for example, let's go back with our HClO3, okay, which we said was chloric acid. Okay, and the HClO3, when it loses an H, becomes ClO3 minus. Now, again, we know that there's other versions of chloric acid. There's perchloric acid, and its anion would be ClO4 minus. Okay, HClO2 was the Chloric Acid, which would be ClO2 minus, and HClO was the Hypochlorous Acid, and its anion would be ClO minus. Okay, so just like we saw with the acid form, for the anions we have a set of suffixes and prefixes that we can use to indicate how far we are away from the original parent compound in terms of the number of oxygens. So when I take a proton, I'm sorry, I should take an H away from a molecule of chloric acid, I get ClO3 minus, and the name that we use for this is chlorate. So notice how the acid part goes away altogether. Okay, so we're using that suffix chlorate. I'm sorry, ate onto the chlor. For the version that has one additional oxygen, we use the prefix per, and we use the root chlor, and the ending suffix of ate. Okay, now I'm going to pause here. I'm going to correct some of the coloring here just to be consistent. Okay, so we fix those up so that they have the same color scheme as what we had before. Okay, and then for the chlorous acid, when it loses its hydrogen, is called chlorite. Okay, using that suffix ite. And then for the ClO minus, we have hypochlorite. Okay, so again, it's a matter of how far you are away from the parent acid in terms of the number of oxygens. Okay, so if I were looking at sulfuric acid, actually let's look at nitric acid. We have HNO3. There's not one that has more oxygens. There's HNO2 and HNO. Okay, the acids here would be nitric acid. That's the parent. Okay, and then we would have nitrous acid and hyponitrous acid. Okay. Now if I take away a hydrogen from nitric acid, I'm left with NO3 minus. Okay, and that is known as, well, let's see here. It's the parent compound. So if we look at the parent compound up here, okay, we take away an H from it, we use the prefix ATE. I'm sorry, suffix ATE. So this is going to be nitrate. Okay. If I take the H away from the HNO2, I'm left with NO2 minus. Okay, so this is the version that has one less oxygen. So this becomes nitrite. Okay, and then HNO, if it exists, would be NO minus, and that's going to be hyponitrite. Okay, and these patterns go on for all of the different oxoacids that I've shown you.